In example 8, it says find the component form of V given its magnitude and its direction angle. And so vector V, you can see that the magnitude, see the double lines, is 5, and that the directional angle is 30 degrees. So this is just to have us practice rewriting this vector in component form. So the first thing we'll do is we'll do our arrows, which is component form, and we'll do the magnitude, which is 5, and then we have the cosine of 30 degrees. That's the horizontal component of the vector, and then 5, and then we have sine of 30 degrees, and that's the vertical component of the vector. Now, if we want to change this vector and rewrite it, we could rewrite it as 5, and then you should have memorized what's the cosine of 30 degrees. Is it the square root of 3 or 3 over 2, or is it a half? It's the square root of 3 over 2. And then the sine of 30, what's the sine of 30? Is it the square root of 3 over 2, or is it a half? It is a half, and those are both positive because we're in the first quadrant. So this vector can also be written as 5 root 3 over 2 and 5 over 2. Ta-da! Last example, I bet you're clapping your hands and cheering. So here we go. This is it. Last example 9, and then you're supposed to try example 10 on your own. Here we go. So two forces act on an object. You have vector u and vector v. We want to find the result of the two forces. We want to find the direction of the result and the magnitude of the result. So the first thing we're going to do is write each vector in component form. So we have vector u, and vector u has a magnitude of 3, and it's the cosine of theta, which is 45 degrees, and the magnitude of 3 and the sine of 45 degrees. So that is vector u. Then we're going to write vector v. Vector v is going to be 4 is the magnitude. We've got the cosine of negative 30 degrees and 4 and the sine of negative 30 degrees. We want to add vector u and vector v together so we can figure out what the result of those two vectors is. All right, so you can add these by simply putting them into your calculator. We are going to call the horizontal part A, and we're going to call the vertical part B. So because these are specials, you could actually do this by hand if you wanted, or you could put it into your calculator and come up with the decimal. I'll just put it into my calculator. So you're going to be in degree mode. You're going to do 3 times the cosine of 45 degrees plus 4 times the cosine of negative 30 degrees. And you guys know what the cosine of 45 is. It's root 2 over 2. And the cosine of negative 30 happens to be root 3 over 2. So you're going to add those two vectors together, and you're going to end up with 5.585. Then you're going to add the vertical component together, so you can put it into your calculator. 3 sine of 45 degrees plus 4 sine of negative 30 degrees, and you're going to end up with 0.121. Something to remember when you're adding vectors in this form is make sure that you always use the directional angle. If the story problem gives you a bearing, do not use the bearing. You have to use the directional angle. All right, so this is the result of those two vectors added together. So now that we have the result, we can figure out the magnitude. So that's going to be the force. So the magnitude is going to be the square root of a squared plus b squared. Now, if you stored the first one as a and the second one as b, then you can just put that all into your calculator at the same time, and you can just use those stored numbers, and the magnitude should end up being 5.587. All right, the next thing we need to do is we need to figure out what the direction is of that vector. So to figure out the direction, sometimes it helps to think of the graph. Oh, help. Hold on. All right, so looking at the graph of the resultant vector, we can see that if you look at the result, the horizontal part went to the right 5.58, and it went up 0.121. So this is kind of what your resultant vector looks like. We are interested in finding that angle of the result. So how you're going to find that angle is you're just going to use tangent, because you know what the opposite side is. That's going to be your B. And you know what the adjacent side is. That's A. And here is A, and here is B. So if we do the tangent of theta is equal to B over A, and you can have those numbers stored in your calculator, here's B and here's A, then you're going to end up getting an angle of 1.244 degrees. So that is the direction of the two forces. So your two answers are here. Ooh, that didn't work. Let's see if I can fix that. All right, let's see. So your two answers are here. That's going to be the magnitude. And here, that's going to be the direction. Now, when you're dealing with the direction, you always want to graph your result. And the reason why you want to graph your result is because you want to make sure that you have the correct angle. Sometimes you will get the reference angle instead of the actual directional angle. Homework is to try example 10. There's two different ways to do this problem. You can try it like example 9 by adding the two forces together, finding the magnitude and using tangent to find the directional angle. Or you can use a parallelogram like we did with the ship problem, and you can use the law of cosines and the law of sines. So give this problem a try. We'll come back next time and do this problem two different ways. Bye-bye. Thank you.